Excellent. Well, thank you everyone for coming out, and welcome to Delivering Security Control at Velocity. My name is Kyle Harper. I am the lead engineering manager of a development team within Cerner. And I have the luxury of leading a team focused on automation, very much through Chef typically, but also in other various forms. And we had the responsibility for helping deliver security controls at Velocity, which I'd like to talk to you today about. Let's see if I can make all the magic work here. Excellent. So, on our agenda today, first I'd like to dive in a little bit to the why, security controls and you. Why does this matter? Then for me personally, kind of how I came along this journey into this passion. How we have in turn codified the delivery and how you can also. How we leverage a community contribution model and how to best utilize the resources available to you. Ways we've been successful in testing early and failing fast to try to shorten the feedback loop. How we then in turn deliver those security controls at scale. And ultimately to be able to pivot quickly and begin starting secure in our provisioning process. And then finally, we'll dive into a few mistakes and lessons learned that we've made along the way, so hopefully you can't repeat the same things we have. Apparently I'm not managing this well. There we go. Security controls and you. So why does this matter? Why do you care about this? Ultimately, we have a responsibility to our clients, right? So Cerner is a healthcare information technology company. So us particularly, as stewards of healthcare data, have a high degree of an upward responsibility, if you will, to navigate the continuously evolving security landscape. Really, frankly, this is the right thing to do, right? What is the value of your client's data potentially? What's the risk, right? What's the risk to your business? What's the risk to your consumers? Nope. There we go. So the reality of the matter is that data is valuable. It's really amazing. Whenever you Google this, I'm surprised how much this evolves and how much this changed what is seemingly on a day-to-day basis. But many records that you might think of, credit cards, other forms of personal information, date of birth, mother's maiden name, and particularly medical records are quite valuable in the black market. Again, why, as a healthcare IT company, Cerner is specifically interested in protecting our clients' data. The reality is that breaches are expensive. From a 2017 study, on average, it cost business $11.7 million per year. This is a costly exercise. But even beyond that, the damage potential to your reputation is incredible. 46 companies were left with damaged reputation and brand value after a breach from a recent study. Ultimately, reputation is priceless, right? No one wants to be on the front page of the newspaper. No one wants to be in the 6 o'clock news. I guess I'll spare naming a few specific companies, but no one wants to be the latest and greatest company that is on the headlines because they have been breached and somehow lost a degree of trust. But lastly, you may simply have contractual obligations to satiate various security controls. Often, these controls are coalesced into a body of work known as a security technical implementation guide, otherwise known as a STIG, which I'll use to refer because that's a lot easier to say. And STIGs really is just one of the many components in a comprehensive strategy. I don't want to give the impression this is the end-all to be-all to implementing security within your organization, but it absolutely is very much an important one. There you go. So what led me into this journey? I'd like to share a little bit of my background history just to provide some context. So in a previous livelihood, I wasn't literally fighting fires, but I was figuratively fighting fires, as I suspect many of us in this room are and have been. In the corner there, actually, that is me on a terrible laptop, on a terrible cellular modem in the middle of a campsite in the middle of nowhere, dealing with a production incident. I didn't like that. I suspect you did not either, right? That was not a happy time, and I'm glad to say, as Cerner has gotten more and more on board with adopting configuration management broadly, but also in the context of security, this has gone away. This is not how I live my life anymore. But we had a lot of reasons to begin using configuration management as a tool to implement security controls. First off, essentially, the current manner, the previous manner, was unsustainable in terms of growth, right? As we scaled larger and larger, manual implementation was simply unsustainable. We didn't have the human power to do what we needed to do and to deploy at the velocity we needed to deploy to be able to do so. Even worse, it led to inconsistent delivery, right? Before we adopted config as code, we weren't necessarily always producing the same thing. The desired state wasn't always the same, right? And this could lead to incidents, this could lead to security risk, really not a great place to be. And then lastly, that manual implementation model really did not facilitate the ability to react quickly and adapt to a really evolving landscape of security. So we began by codifying delivery. And really, how in doing so do you define that target end state that you care about? So first off, if you take one thing away, take several things away this hopefully, but is that treat security code as config like any other product that you produce. Treat it as a first-class product with the same degree of diligence that you would treat anything else. And when you do so, you really gain many of the benefits that you would have through other forms of agile software delivery, right? So I'll refer to this loop here. I know there's a lot on here. Bear with me for a second here. But at its core, I want to highlight this life cycle. And like all great IT processes, it seems like it ultimately ends up being a feedback loop, right? We'll begin by codifying these security controls, implementing various ways of integrated testing those security controls, leverage a collaborative review to ensure that they are both accurate and desirable, ultimately produce a version state artifact, which we then deliver at scale, and then audit backward compliance, which then feeds back into the codification. And like I said, we'll visit this on several occasions throughout this. So to begin with, this is a platform to iterate, right? I think it's very easy, particularly when you look at some of these controls, some of these STIGs. There can be literally hundreds of controls, and you're probably being held accountable to a wide variety of STIGs, right? That's overwhelming, and that's a lot to try to buy off immediately, right? That was very much the case for us. And so we started small and began to build upon that, right? Take one STIG, take one subset of controls, take one little piece of technology and tackle that, and then build upon that. If you try to immediately boil the ocean, you're going to be overwhelmed. To give some context, for one of our cookbooks that delivers one of our STIGs, that is nearly 800 commits, about 400 pull requests, and about 11,000 lines of Chef cookbook code. Right? This is not trivial. It took us a long time to get there. That's really 4 or 5 years of iterative improvements, enhancements, defect corrections, right? It's taken a while to produce this body of work. So don't be overwhelmed by the initial breadth of what you're trying to accomplish. But as you begin to define as code, I'm super excited to see this, I think, reiterated in other forms this morning in the keynotes, is that this is a universal language. This is an opportunity for you to collaborate between operations, development, and security. So if you have the luxury, and I'm jealous if you do, of having those responsibilities in a cross-functional team, even then this is beneficial. But particularly if these are belonging to different organizations, if there is, despite your best intentions, if there's potentially silos between these responsibilities, this is an opportunity for you really to come together in a common language and a common code base and articulate your desired attention. This code clearly states what you want to be your outcome, right? And even further, it self-documents, right? It is fairly unambiguous in what you are trying to achieve with your system security configuration. So to give an example of that, how this becomes somewhat a transparent code, this is just some simple configuration to set OpenSSH, something we probably commonly have to do, specify a protocol version, some other options in OpenSSH, ignoring ARC hosts, not permitting empty passwords, right? And what I love about this is that anyone, I think, who has any familiarity pretty much with technology can look at this and probably understand what the goal is, right? There's not a whole lot of ambiguity here, right? And this really means that as someone who's in ops, as a developer, as a security professional, we all can be clear that this is our desired state. There's really no confusion here of what we're trying to achieve. So as we began this journey, we really began to learn and try to best leverage a community model. And I mean that both externally and internal to our organization. Really, frankly, how can we source control all the things has been incredibly key to us. So in our life cycle here, we're really touching on two at the same time, so bear with me. But how do we kind of leverage the external community to, as input into the codification of these security controls? And then once we start producing this, how do we leverage a collaborative review across the organization to make sure that we're producing our best outcome? So first off, it's been incredibly benefit for us to leverage the public chef community. I mean, a theme I think you see and hear a lot today already too. We, of course, have special edge cases with which we have had to go do something proprietary, or we've had to tweak things here and there. But a good chunk of what we mechanically depend on and leverage to implement security controls is out there publicly in the community. There's a lot of great cookbooks to kind of manage these various aspects of the system. But then we've also had to do a lot of internal. And this is where I think we've been incredibly successful, is fostering an internal community. So, and that's kind of a very tiny there, if you will. But this is a small snippet. I just picked the top 8. On one of our security cookbooks, we have about 50 contributors. And easily, I'd say 20 to 30 of those are very, very active. This is absolutely a model in which we have participation from a wide variety of experiences, which is great, right? Within your organization, you probably have exactly that, right? You have a diverse set of experiences, a broad set of expertise. You really want all those folks contributing and participating in this conversation. By having that internal community too also, you're really enforcing a control plane as you integrate this in with source control. The control plane to implement process, policy, whatever is necessary for your particular organization. Something as simple as mechanically, I need to have these particular roles participate in a pull request, or had to have certain approvals from certain people, or things like that, right? And again, just to reiterate, this gives us a common language for us to have that conversation. When we're having that conversation, I love pull requests. I love technical debates. I hope later someone challenges me because I want to talk about it. It's so much fun. But it needs to be respectful, obviously, right? And that's really an underlying culture theme amongst this, right? Let's have a disagreement. Let's make sure that we are all on board and that we are achieving our optimal security outcome. But let's argue a little bit, right? Let's butt heads a little bit. I think that's great because it means we're thinking about it. We're not just mindlessly going along with the status quo. Like I love that spirited debate that often happens in pull requests. But in that, I'd like to emphasize a slight distinction between a maintainer and versus an owner philosophy, right? As mentioned, I do have a team that has the luxury of focusing on this a lot. But I very much view ourselves as maintainers, as we are part of a broader community that's all contributing and participating in. And by that, we are not the exclusive code contributors. We participate very heavily in the pull requests. We participate very heavily in the architectural design and kind of implementation strategy. But we are not the only implementers, right? Frankly, we couldn't be. There's no way we could do this if it was just my team. It's just, the scale is too large, right? As opposed to an owner, which is, this is not right, this doesn't meet my need, I'm going to throw this over the wall and engage you to go make this happen for me, right? That's really not the model we have, and it's not a model that we've seen to be successful. We want the folks who have the need to be heavily involved with, hopefully literally issuing those pull requests to the body of code to make it evolve and make it adapt. And we will help facilitate that conversation and help facilitate the releases and some of the other mechanical things that might need to happen to get that available. So, we've begun to codify the delivery, though. So how do we test that? How do we shorten that feedback loop? And to use a kind of catchy catchphrase, how do we shift that testing left? So back in our life cycle here, we're really jumping into this integrated testing. And how do we use frameworks and other mechanisms to gain confidence that what we're delivering satiates and satisfies our desired outcome? So in a traditional model, or I say a somewhat antiquated model, we might create a piece of code, create a cookbook, release it, provision it, get a server configured, audit it, and that's ultimately when we find out, are we compliant? That's really late in the game to get that news, right? That terrifies me. That means that I am going to be incredibly slow to react, and I don't feel very proactive in ensuring that we're delivering what's needed, frankly. So as we begin to shift that testing left, through various methods of continuous integration testing, we can shorten that feedback loop. Within the context of our development ecosystem, as my engineers are still working on this on their laptops before even things hit source control, I want them to have feedback on what they're achieving, or what are they doing? Is this actually satiate the need? To do so, there's lots of leveraging, or rather lots of testing frameworks you can leverage. For those familiar with Chef, I'm sure many of these already sound familiar. Server spec, inspect, of course, are two common ones. The things that I love about these is that they're incredibly human readable, right? Up here is an example of just some service spec to disable some services. Again, I feel like that a lot of folks can take a look at this, and even if they're not necessarily familiar with service spec testing, get a good feeling of what this is probably trying to do, right? We want these services not to be running and not to be enabled, right? And then likewise, the output, I think, is incredibly descriptive. We haven't gone as far as to actually use the output of the service spec testing for a burden of proof, but frankly, I hope one day that we can, is that descriptive that hopefully we can use this as evidence that we are doing what we're supposed to be doing in some kind of audit. Once you have created those frameworks, once we begin leveraging those frameworks, there's really a lot of amazing opportunities to do clever and interesting integrations with that. One we've had great success with is integrating that into our source control lifecycle. So I mentioned we have a community. We ask that our contributors fork and they issue pull requests in. And by integrating these tests into our source control lifecycle, by having literally, frankly, GitHub call Jenkins and make some magic happen here that I'll go into in a moment, we get really fast feedback and immediate feedback on the nature of that change, right? It allows us to, first off, automatically test some things that, frankly, computers are great at testing, right? The linting, things like Robocop or Test Kitchen or other kind of cook style, things like that. There's no reason to have a human wasting their time finding subtle linting errors, right? Let's let the computers do that, right? And we can get that feedback fairly early on with every pull request. And that empowers the reviewers to really focus in on the architectural decisions, the implementation decisions. They're not really wasting their time on just syntactical concerns that aren't necessarily ideal. But it also gives us great immediate feedback onto the nature of the pull request. You know, has someone created the tests, the spec tests they need for this? Have they inadvertently, while trying to satiate one control, potentially broken another that they had not anticipated, right? So having that integrated into our source control lifecycle has been incredibly beneficial to us. And when we do that, that helps us really orchestrate a breadth of tests. There's quite a few standards with which we are held accountable to and that we have interests with. And we also have quite a few platforms that we are deploying this onto. So in this particular example, this is out of Jenkins. You can see we're doing some cook style, some food critic. But then in parallel, we are running both a CIS-based standard and a DISA-based standard against OAL in 6 and 7. And previously, we do this entirely on our local laptops. And to be frank, that's about 5 hours worth of testing before we even knew whether we were successful or not. That's really painful. I mean, it's better than finding out, I guess, days later on the actual real server, right? But even local to our laptops, that was a really slow feedback loop. That was not very effective. So by having these tests automatically kick off with the pull requests, we can execute a lot of this in parallel at a capacity that we just simply can't accomplish on the local devices. We just don't, unless you have the best laptop known to man, right? We can't realistically run all that in parallel. And that has helped enable and kind of helped shorten the feedback loop to a matter of 30 minutes. And we keep really bringing that in more and more as we streamline our tests. And to do so, we've had great success leveraging the cloud essentially for testing scale. Don't worry about seeing the nitty-gritty of this, but this is just an example of a test kitchen config with which we are using an internal OpenStack as the kind of backing driver for our integration tests. So with every pull request, OpenStack VMs are being dynamically spun up through Test Kitchen. The tests are executed, and we get that feedback loop, and it even feeds back into GitHub, giving us that visual kind of indicator that these were successful or not. And that really gives us a lot of parallelism. I mean, this is our tenant with which we do that. And honestly, by OpenStack standards, this is a tiny little tenant. But from a testing perspective, this is a wealth of capacity for us to leverage. We have, we can run 16 tests, and honestly, we could quadruple that and not really hit a wall, right? There's a lot of power backing this, a lot of parallelism that we can leverage to have these tests run in parallel and to run fast. We happen to use OpenStack, but by no means is it's limited to that. There's a lot of really interesting kitchen drivers out there, whether it be AWS, whether it be Docker, you name it. There's a good chance there is a way to hook that together to have tests execute somewhere other than just literally Vagrant. And don't get me wrong, Vagrant's great. I think it serves its purpose. But when you really want to start testing at scale, it can have its limitations. So as we've gone down these tests, one of the challenges we encountered is really how to manage leaks. And by that I mean, it's hard not to inadvertently interject some piece of human knowledge into your testing, right? The person who's writing the test is also the person who, frankly, wrote the piece of code that's supposed to satiate the test, right? So how do you not write the test to artificially satisfy the requirement, right? And we try to be conscious about this in code reviews. We try to catch that and things like that. But what we found is that sometimes, despite our best intentions and despite the fact that our design tests were passing, later on, we'd be failing some external audit for something that we thought we had addressed, right? And one of the ways that we've tackled that is to actually consume the external auditing that we will ultimately be held responsible for into our integration tests. So if you're not familiar with SCAP, it's a common framework for kind of automatically executing tests, and one that which we are often held accountable for a lot of the various STIGs out there. And what we've had good success in is actually running that SCAP profile in our integration tests at the time of dev, in that dev lifecycle. Don't worry about catching the specific code, but the gist is that we're running SEC. Now, it happens to be because of our federal need, but we're running SEC to literally execute the SCAP file and give us feedback. So if SEC comes back with a control that's failing, that rolls up into a RSpec test, which then in turn fails. So we have a good canary, if you will, that what we've changed, some change we've made or some evolution of the STIG has resulted in us ultimately not failing the audit, which we'd be held accountable way later in the life cycle of the system, right? And having that feedback early on has been incredibly beneficial. So once you've codified this, once you feel confident in your testing that you're producing an outcome that you desire, how do you then in turn deliver that at scale? So visiting our loop here, at this point we're really getting into creating that version state artifact and then deploying that at scale, particularly with the idea and context of helping manage drift. So when you do deliver at scale, one of the immediate outcomes and one of the immediate things that we saw is the time savings. It's unavoidable. I'll say it's unavoidable. I guess you could avoid it, but it's hopefully undeniable, right? For some of these STIGs, to implement that manually, to simply bang away at a keyboard and make all the configuration changes necessary, we're really talking at about a day. I think a day is being a bit optimistic. I think for reality, for some of these, it'd be more like a day and a half, 2 days of an FTE, just manually changing text files on a system, potentially, if it's Linux, right? And what we've brought that down to, it's about 30 minutes of a Chef client run, right? And that alone, I think, is pretty remarkable. But then when you scale that to the fact that we're applying this to 20, 30,000 now, I think now is nodes, the time savings is really insurmountable. And this is coming from what is really ultimately not that large of a development investment. The return is really quite remarkable. But equally, if not more importantly, is that we are getting consistent delivery by implementing security controls through config as code, right? It means that every time we go do this on a node, we can feel with a high degree of confidence that its security state is what we have articulated through our code, right? We can define that target end state and repeatedly converge and make sure that we are helping minimize and eliminate drift. I think what's really incredible about this approach is that you produce a versioned artifact that represents a point in time of your security posture, right? It's something that you can easily reference to. And really, it enables the strategic and somewhat intentional adoption of that. So for example, if we needed to modify a file permission on some piece of configuration on our nodes, right? We can change our cookbooks to reflect that, and that becomes ultimately a version state that allows folks to adopt that at the rate with which they're capable. So they can test that in the context of their specific solution. Cerner does own and provide a breadth of solutions and products, right? And not everyone looks the same. So the ability to adopt that and bounce that through their domains and progress that through domains at a rate that they're comfortable with is incredibly valuable. And then from our perspective too, it allows us to audit that, right? We can see who is running what version of what cookbook. We can know where our gaps are. We can know where there's still a body of work to go accomplish. And we can know where there's potentially risk because they have not taken this new version of the cookbook, right? It really empowers an intentional and, I guess, structured adoption, if you will. I love the fact that if we need to, all the great things really you get, I feel like I'm preaching to the choir here, from configuration's benefit. Like, we can move back, we can move forward. It's a complete snapshot of what our security state is right at that moment. And it really helps us manage drift. We've tried a wide variety of methods, I guess you say, to managing drift. In its most simplistic form, in some areas, we run a demonized chef client, and it's wonderful, right? To have that chef client run a daily or whatever the frequency makes sense for you, and to know that every time that occurs, it's applying these security controls and ensuring that we are staying in a secure state. For some of our solutions, where demonized chef client is a bit architecturally challenging, we've done things like have an external orchestrator in turn run chef client, right? And that still ultimately accomplishes the goal. It's just something else is periodically running chef client across a span, right? And then ideally, as we transition into more ephemeral systems, the drift becomes even less of a risk, right? Because the systems don't really exist that long. Every time we spin up a new system, we are reapplying those security controls, and the system goes away in a short period of time. So as we codified this, one of the great benefits we've also seen is the ability to really then bake that into our provisioning pipelines, and enabling us to be able to start secure. So in our loop here, still kind of delivering at scale, but this is really integrating it into that secure provisioning. So what's been successful for us, and there's, I imagine, quite a few ways to tackle this, but we've had great luck using Packer and Chef combined as a way to actually create a pipeline of producing secure images. And one of the things I love about this is that it allows us to leverage the same code, right? Don't worry about necessarily catching the nitty-gritty, but what I want to point out here is that we're running Chef Client in a local mode as part of our Packer provisioner, right? We are literally running the same cookbooks. Everything's the same. We're even using similar configuration, roles and environments that we use out in the wild to build this image, right? We're not having to maintain multiple code bases, and they really both get the benefits on both ends of the spectrum, if you will. By leveraging that same configuration, we start as secure as we end, essentially. And anytime we make an enhancement because we found a deficiency at the end, that feeds back into the start, right? We learn from that, we codify that, and going forward, we provision with that enhanced security. It also helps us provision with the latest patches, and this has been really incredibly impactful for us. We have a concept of what we call a patch week set. And in doing so, we, every week, take a snapshot of all our Yum repos and of all our external repos that we consume and things like that, and which allows us to give a specific point in time that we can reference, right? Of 2019, we're on week, I don't know what it is, let's say 20, I think, probably close to it, of Red Hat, for example. And that's the point in time that we can consistently reference and repeat. And what we can do is, as we provision securely, we can always make sure that we're using the latest week. We're literally using current. So every time we create new images, which we do on a weekly basis, we are baking in the latest patch set. As a side note, this has also been this concept of a week has been incredibly benefit even for maintaining the life cycle of long living nodes, right? It's a patch set point in time that we can treat like any other piece of configuration. It's just another attribute of the system that we can test and dev and roll up to our environments, right? So you can have a high degree of confidence that that patch set is compatible with your solution. So once you do codify this, once you feel confident in your testing, once you're beginning to deploy at scale, it's been really quite remarkable how easily we can pivot quickly and how easily we can adapt to change. In our lifecycle, we're really getting into now how do we audit for that compliance, and how does that feed back into our code base. So I mentioned earlier that we run the SCAP test as part of integration testing. That literally is an attribute we set. This happens to be, I think, some DISA Red Hat SCAPs that we're examining. But that's just an attribute. So the second these get updated every quarter, we literally change 2 attributes in STIG or test suite, and we start testing against that latest SCAP file. We get that immediate feedback as to whether that potentially is causing a breaking change. Of course, we still evaluate it with a human brain to kind of see, read what's changed, read the delta, read what's new. But it's been really beneficial to just mechanically just be able to update a variable and immediately start gaining some confidence that our code base either is deficient or kind of find the delta, if you will, from the evolution of that STIG. But then we very much have been leveraging NSPEC as an audit mechanism. And I'm sure many folks will say this stronger than I will today, but I love NSPEC. This is an example of just monitoring some SSHD config. And again, a reoccurring theme here is that it is incredibly human readable. the resources available to you within InSpec really, in the same way that configuration as code help provide a collaborative and a universal language to articulate the remediation, InSpec we have found to be incredibly valuable to clearly articulate the audit of that, right? At a minimum, I would encourage you to have a feedback loop, whether it's process or policy, that those being audited kind of at the edge are feeding back into your configuration as code pipeline. Ideally and optimally, is what has been quite successful for us, is that really those who are heavily involved in that audit, those who are at the front lines, are part of the community that collaborates on top of this, right? They're the ones submitting the pull requests. They're the ones, frankly, feeling the pain, and they're the ones who know the deficiency intimately. So I love it when we get pull requests from them to further enhance this body of work. As we've gone down this, and as we've had a need to pivot, it's really been remarkable how quickly we can. So to give an example, we had a new STIG with which we needed to contractually be accountable for. And initially, we were not terribly compliant. It was our first journey in this particular STIG. We had a team of just 4 software engineers, just over a 2-week sprint, be able to elevate our compliance from 44 to 90%, and we've gone quite a bit since then, right? But just in 2 weeks, we went from 40, we doubled our compliance, right? And then that's being used across thousands of nodes, right? It's really incredible how a small investment can be reused broadly. The savings are really quite remarkable. So as we've done this, we've made some mistakes. There's no way around it, right? We've learned a few hard lessons, which I would hope you cannot repeat. So first off, is that don't assume all systems are capable of the full STIG. When we first wrote this, we were quite aggressive. Mechanically, literally, in our cookbooks, we were using force override and things like that for attributes, right? We didn't really give people a whole lot of options in this. And the reality is that that's idealistic, right? Solutions, for various reasons, will have needs to hopefully only temporarily opt out of certain controls, right? And we have had to make updates to our code base to mechanically facilitate that, to use lower attribute precedents so that we default to the ideal state. But allow consumers to override that, hopefully temporarily, as they make changes to their solution, their architecture, to enable that compatibility, right? Second is to be mindful of dependencies. We originally very aggressively locked down our cookbook dependencies. And with a cookbook of this nature, inevitably, and hopefully I'd say actually, is that it's being used broadly, right? This has the potential to have broad use across your organization to cross multiple solutions, multiple products. So there's lots of opportunity, unfortunately, for dependency conflicts. And I think today we've heard some interesting other solutions to that. But one thing we've noticed is that if we're a little looser with our dependency controls, but instead build testing pipelines that we use to gain confidence, that we trust to detect breaking changes, we can be looser, right? So instead of locking down to a specific major version, be a little looser in that, but make sure that your testing pipelines would detect if a new version change actually does break that. And that helps reduce the likelihood of running into conflicts with other kind of layered technologies and cookbooks that might be ultimately utilizing a shared resource. And lastly is that don't fear major releases, which may sound a little counterintuitive, but don't let your desire to be non-passive hinder you from implementing your best security controls, right? Certainly be non-passive if you can, right? I mean, I think everyone appreciates that. But at times we found ourselves striving so hard to maintain passivity that we were doing hacks, to be honest, that we weren't necessarily taking the best approach to implementing these security controls. Obviously, adhere to semantic versioning. Make sure that changes in default behavior are being appropriately represented in your semantic versioning. And be transparent in your publication of the changes. Again, particularly if this is being broadly consumed. But be willing to make major version changes. Be willing to maybe break passivity. Just be very clear and transparent about that. So a few suggestions as you begin this journey, if you have not started going down it. I hope if you take away a few things from this, I hope these stick with you. First off is that just start implementing a few controls. Start small, but that they help codify and kind of enable that iterative and community-driven agile software delivery. Don't try to do everything at once. Start small and build. As you do so, help unite dev, ops, and security towards a common and transparent goal by speaking that universal language that is code. And this has just been immensely valuable to be able to clearly articulate our desired end state. As you go down this journey, absolutely leverage testing frameworks to try to shift that testing left. And when you do so, as you shorten that security feedback loop, I think you'll find that you really help increase your velocity and your ability to adapt to the change that you're being tasked with. And then lastly, reduce your risk by leveraging the consistency that you gain by using security as code. And ideally, if you can, begin considering integrating those into your provisioning pipeline so you start as secure as you end. That's it. I thank you guys for your attention. I'm happy to field any questions. I know many of this was at a higher philosophical level. If anyone has, I'm happy to dive into more detail as much as I can. Admittedly, being security oriented, I have to be cautious on some aspects, but I'm happy to field any questions if there are any. Thank you. Yeah, go ahead. I think they might have a mic for you.
Anyone who has questions, we're going to bring you a microphone so we can capture them in the recording.
Yeah, hi. How do you deal with remediating security controls on an app that just is going to break when you implement those controls, especially senior citizen apps?
So I like that. I've heard so many various ways of describing legacy. It's like we're all trying to avoid the term legacy. Apparently it's gotten a bad connotation somehow. Was it heritage or other things? I'll be frank, that's been a challenge for us. Ultimately, I think two aspects. Don't let the fear of the unknown scare you away. There's been times when we've had applications that we thought there's no way we'd be able to implement the breadth of security controls we need to do. And as we started going down that journey, as we started testing, we were pleasantly surprised. I think varies from STIG, but a lot of these controls are really common sense, and there's a few hard ones. I mean, that's unavoidable. If you can immediately turn on SE Linux for your app, more power to you. That's impressive, right? And if you can immediately turn on a node-level firewall, that's also a little challenging. But there's ways really to iterate across that and to kind of discover where that compatibility is, right? Like I said, we've been pleasantly surprised. Not everything's been as hard as we feared. But the reality matters that some things absolutely have incompatibilities. And to my point earlier, what we've provided is mechanisms to temporarily opt out of those controls, typically because the application needs to make some kind of architectural or deployment change to be compatible with that particular control set. For example, a common control you might see is disabling no exec on TMP, right? We're not going to execute anything out of TMP on Linux. As you see, fairly common. And unfortunately, there's some applications out there that want to do exactly that, right? And not to say that they can't adapt and be compatible with that, they just might need to spend a little development time making that architectural change. So providing the ability to temporarily opt out and then opt back in. And because it's configured as code, that can all be easily tracked within your development process, right? This isn't something they've opt out and then we forget about it until years later when we have a breach or we're failing some audit. It's something that you can tightly integrate in with your development lifecycle. And particularly if that configuration as code's been source controlled, we can literally point, here's a piece of code that we need to go change whenever we fix this, right? And that's really been empowering for us. Thank you. Any other questions? Yeah, please. All right.
So when you are rolling out these controls and you find out that it did break something, in your cookbook code, are you also putting in there the flip back feature? And is it some sort of like an attribute, the feature toggle, or?
It's a good question.
I'm just kind of curious because we're actually starting down this path already and found some that have been breaking.
Absolutely. I think you'll find two scenarios there. For some of the controls, it's very binary, right? It's very easy to undo, to be frank. This service should not be running. Okay, well, great. Like, we disabled the service that broke something. Oh, let's turn it back on, right? That's fairly easy to make an attribute change and potentially to modify. If you're, say, templatizing a piece of the config, it then becomes a little harder, right? Like, what was the previous state? And that really has been more of a roll forward scenario in that situation. Like we overwrote this config, we overwrote SSHD, and we figured out that this should not be set this way. Now, we don't go entirely back to the previous state. We just make the attribute change necessary to address that particular incompatibility. It is a little harder. We gone as far as to consider, like, oh, maybe we should have some mechanism that captures the default state and try to somehow return to that. And frankly, it didn't feel terribly deterministic. We'd rather continue to manage that piece of config, just manage it to the point at which we know it to be compatible. Does that answer your question?
Yeah, it did.
Okay.
Hi, so in one of the slides you had on parallel STIG and CIS control, it seems. So what has been your experience? We are trying to implement both CIS and STIG, and we saw that CIS getting that 100% level benchmark has been more tough than getting STIG. So I would like to get some insight as to how you guys went about it.
It's a living beast, honestly. I don't want to give the wrong impression. I wish I could say that we were 100% compliant with everything. No, it's not the reality. It is a continual evolution of both the configuration as code to implement it, right? Because the controls, the STIGs evolve. So the target that we are trying to achieve continues to evolve. But then likewise, our solution's ability to fully implement that is also a living life cycle, right? So I wish we could say we're 100%, but no. There's always a thing here and there that maybe we need to go, some technical debt we need to go address within our solutions to bring compatibility to that control.
And what you also had mentioned as the lessons learned is not every app can meet that benchmark. So in that cases, how do you ensure that the auditors are aware that you could not meet it because of certain...
I gotcha. And I think that will vary a lot from regulatory body, if you will. Okay. So that might, it could be a form of risk acceptance. It could be a form of a POAM or things like that. It might vary from who is governing you. But I think you'll find that often there is a mechanism for which to articulate and document that we can't do this quite yet, but here's our plan to correct that, right? And the great thing is that once you execute on that plan, once you've done the development work to uplift and bring compatibility to your solution, your product, is that it's easy to go flip that back and to implement the control now, right? Like because it is configured as code, it's not something that's been lost and forgotten, right? You can track that evolution and you can track the evolution of that state.
Okay, thank you.
Thank you. Any other questions? Thank you for the questions, by the way.
The question is more around the structure of your profile, the tasks. Do you put them in a separate repo, or they stay with other cookbooks? And also, do you have naming conventions? How do you know which control you have or which one you're missing? When you realize you need to implement a control, how do you know if you already have something there?
Fine. So the stance we've taken that partially has helped us implement, I guess, the breadth is that we default to our most secure posture that we can possibly do, right? So that means we can test for that, right? So if there's some deficiency in our testing, typically we are able to find that. This may sound silly, it may sound obvious, but comments go a long way in our usage of this. For every control that we are setting, because sometimes it's not always, to counter what I potentially said earlier, it's self-evident, but I mean, I need OpenSSH to have this particular version protocol. Okay, that's great, right? But why? What's the reason behind that? What controls are tied to that? And particularly if you're satiating multiple STIGs, when there's often a lot of commonality, they're all going to have some unique identifier that inevitably is different, right? So having very thorough commentary in our code base has really helped us to tie that all together, if you will. And it's particularly beneficial when we get some random consumer who wants to know more about this. It makes it very easy to point someone to the code base, point someone to the set of attributes that are tied with that particular control. And just on the off chance that it's not necessarily that self-evident. I feel like I haven't quite answered your question. Does that help?
Yeah, I'm kind of thinking through.
Okay.
Yeah, we can talk later.
Okay.
I think we probably have time for one last question.
I was just wondering, when you first started down the path, did you do automatically test and correct, or did you leave it sit for a bit, and here's the evidence that we need to go down this path?
We painfully actually did the hard thing first, and as opposed to the easy first. We developed the body of work to remediate automatically through configuration as code before really we went down the journey of auditing, which in hindsight feels very counterintuitive. So we read the STIGs in their full glorious detail and began kind of banging away at creating a code base that could implement those. We are now on the tail end getting better at actually auditing. So the common theme of trust but verify, we trust that our cookbooks do what they're supposed to do. And we have a high degree of trust because of the integration tests that we've created. But ultimately, we want to improve that verification loop that we have on the tail end.
And unfortunately, we're out of time. We need to get ready for the next session. But there's always the hallway track to continue this talk.
Yes.
And thanks for the great speech. Let's give him one last round of applause.
Yeah, thank you so much. I appreciate it.